Welcome to 6.3 Solving Trigonometric Equations Part 2. Example 2. Solve cosine 2x equals sine x over the interval 0 to 2 pi. So this is a different situation than we saw in example 1 because we now have two trig functions and the inputs are different. So here we have a cosine of a 2x, and here we have a sine of an x. So the inputs are an x and a 2x, and that makes it very difficult to solve unless there's a way we can get it into just one input. And what do you know? We have our double angle identities for cosine. So remember, there are three different identities for cosine of 2a. We have cosine squared a minus sine squared a. That's the direct derivation from our cosine, cosine, sine, sine, or couscous formula. Then we have 2 cosine squared a minus 1, or 1 minus 2 sine squared a. So all three of these would work, but one of them is going to be much better than the others. So since we have a sine x in our equation, we're going to want to replace cosine of 2x with something that involves sine, and that is this one right here. So wherever we saw that cosine of 2x, we're now going to replace it with 1 minus 2 sine squared x equals sine x. Now, observing this equation, we see there is a sine squared and a sine. So this is quadratic in form. We need to set it equal to 0 to be able to factor it. Now we want to be very careful on which side of the equation we go. We really want our sine squared to be positive. So if we left it on this side, our sine squared would be negative, which is not good for factoring. Therefore, we're going to move everything to the right side. I'm going to add 2 sine squared x to both sides and subtract 1 from both sides. When I go to write this, I'm going to be sure the sine squared is first. So 2 sine squared x plus sine x, since that's positive, minus 1, and that now equals 0. Now, I will factor this using guess and check, but if you prefer the star method or factoring by grouping, feel free. But the numbers are so small here that guess and check makes it really nice. So I need two things to multiply to 2 sine squared x. So 2 sine x times sine x, and two numbers to multiply to negative 1. So that's going to be plus 1 and minus 1. We do have to check since we don't know if that plus 1 or minus 1 is correct. So we have to check our inner and outer. So we get plus sine x and minus 2 sine x. But when we add those together, we get negative sine x. Let's see, does that check out? Oh no. We actually got a negative instead of a positive. But the number part is right. The 1 in front is correct. So that's a guarantee that if we just switch the positives and negatives and make this into a minus and that into a plus, then we will get that correct. Of course, you could go and check again if you wanted to be certain. So now that we have factored equaling 0, either factor must equal 0. So 2 sine x minus 1 equals 0, or sine x plus 1 equals 0. Solve for each of these. Adding 1 to both sides gives us 2 sine x equals 1. Dividing both sides by 2 gives us sine x equals 1/2. Subtracting 1 from here on the other equation gives us sine x equals negative 1. So taking a look at sine x equals 1/2. There are two quadrants where sine is positive. That's going to be in quadrants 1 and 2 because our y values are positive. Sine is 1/2. That's going to be a 30-degree reference angle, or in radians, that's pi over 6. In quadrant 1, that is pi over 6. But here, since this is pi, or 6 pi over 6, that's 1 less pi over 6, so that's going to give us 5 pi over 6. So we get two solutions here, x equals pi over 6 or 5 pi over 6. Now, for sine of x equals -1, that's going to be a quadrantal. And since the y value is -1 there, that angle is 3 pi over 2. So putting this all together, we get pi over 6, 5 pi over 6, and 3 pi over 2. Remember when we have equations quadratic in form, once we get here, and we're expecting 4 solutions, or we're fishing for 4 solutions. Similarly, once we get down to our factors and we solve each factor can give us 2 solutions. However, our special quadrantals sometimes only give us 1. And then if the number here is outside of the range of sine, then we might not even get any solutions. Like for example, if we had sine x equals 2, this would not give us any additional solutions. Let's take a look at the practice. Again, you could always try this on your own. So solve sine theta equals sine of 2 theta over the interval 0 degrees to 360 degrees. So again, notice we have 2 different inputs into our trig functions. We have theta and 2 theta. This is when we want to use our identities. So we only have one identity for sine of 2 theta, and that's 2 sine theta cosine theta. So we know we're going to need to replace the right-hand side with this 2 sine theta cosine theta. So we end up getting sine of theta equals 2 sine theta cosine theta. Now, even though we don't have any squareds, because we have a sine theta times a cosine theta, that makes this still quadratic in form. So we will still set it equal to 0 and solve. So I will subtract sine theta from both sides. These are not like terms, so we just get 0 equals 2 sine theta cosine theta minus that sine theta. What to do? We're trying to factor, but this is going to be different factoring than what we did in our trinomials. We first want to see, is there a GCF to pull out? And yes, we can factor a sine since both terms have sine theta in it. So when we factor out a sine theta, the first term we're left with 2 cosine theta, and as a placeholder, we're going to get -1. Now that it's factored and equaling 0, we can set each factor to 0. So either sine theta equals 0 or 2 cosine theta minus 1 equals 0. Sine theta equaling 0 is going to be quadrantals, and that's our y values equaling 0. So that's going to be here and here on our x-axis. So we get theta equals 0 or theta equals 180 degrees. For the other equation, 2 cosine theta minus 1 equals 0, we first add 1 to both sides. So 2 cosine theta equals 1. Divide both sides by 2. So cosine theta equals 1/2. Cosine of theta is positive in quadrants 1 and 4. And if the cosine is 1/2, this is going to be a 30, 60, or 90, but the x value has to be smaller. So that's going to be 30-degree or 60-degree reference angles. So in quadrant 1, we get theta equals 60 degrees. In quadrant 4, we're trying to find the angle starting at 0 all the way around just to that point. So we want to take the 360 and take away that 60 degrees, and we're going to be left with 300 degrees. So over here, we get theta equals 60 degrees and theta equals 300 degrees. Putting our answers all together, Some people like to list them in increasing order, so I'll go ahead and do that. We get 0 degrees, 60 degrees, 180 degrees, and 300 degrees. It is also totally acceptable to just list 0, 180, 60, and 300. The order does not matter. The one thing I want you to see as the pattern here is that when we have two different inputs, one's a theta and one's a 2 theta, or one's an x and the other's a 2x, that's when we want to use our double angle identities. I hope you enjoyed this video. See you next time.